Welcome to statistical learning session. Today we'll be continuing from our previous session where we talked about chi-square test, main ideas. In last session, what we did was we took the first derivative of expression we had. This is the expression we had, and we took the first derivative here for Bernoulli case. Now, our job is to do the second derivative in this session. So let's proceed. Can you tell me what would the second derivative look like of this expression? Think about it. Let me show you the second derivative of this expression. D, L, P and dp would be look like dp square and square of this, and it should equal to xa indicator and p square indicator xa 1 minus p square. So this is what the second derivative of this expression look like. Now our job is to take this expression and say second derivative of that. That is, this expression is a derivative of log likelihood of p with respect to 1 minus p, and we'll take once again second derivative with respect to 1 minus p. So let's do that. So what we have here is d l p and d 1 minus p. Can you think for a few seconds what would this be equal to? Let me show you. This should be equal to 1x equal to a1 and p square, same as before, and equal to minus indicator x is equal to a2 1 minus p square. It's same as before, no change at all. These are for diagonal terms. Now for third expression, this is the off diagonal term. What we're going to do is we'll take the log likelihood of p and take the derivative with p and 1 minus p. So it's going to be a second derivative, of course, with dp and d 1 minus p. And what should be equal to? Can you guess? Can you think for a few seconds? This should be equal to minus 1 indicator x a2 1 minus p square plus indicator x a1 p square. Now let's proceed further in our calculation and take the expectation of these values. What is the expectation of this? Think for a few seconds. The expectation of this is 1 minus p minus 1 minus p, and this should equal to minus 1 p 1 minus p, and expectation this is same because expression are same, so it's going to be 1 minus 1 over p minus 1 minus p is equal to p 1 minus p. Now for this off diagonal term, it's going to be different. We all know that. And expectation is 1 by p minus 1 by P equal to 2P. P 1 minus P. Now we have completed our calculation. So let me quickly summarize what we learned today. So we continued. We had this expression from our previous session, these two expressions. We took a second derivative of that. For first expression, we took the derivative with respect to P, and it was second derivative, and this gave a certain expression. And we took a second expression, and we took the second derivative with respect to 1 minus P. And we again went back to the first expression, and then instead of taking the second derivative with the P, we took second derivative 1 minus P, and we had this expression. So we took all the three expressions and took the expectation of that, and they gave us these expectations, these expressions. Now it is worth mentioning that these this calculation shows that the Fisher information is same whether we parameterize it by P or 1 minus P. This shows the symmetry of Bernoulli distribution, and the variance would not be different if we choose parameter if we choose parameter if it parameters by P or 1 minus P. The variance would not be different. So that's all for today. I'll see you next learning session. Thank you so much. Have a good day.